Hello everyone, welcome to the 7th episode of our example problem series for Circuit Analysis 1 here at NDSU. In this episode, we are going to focus on node voltage, which is a very important circuit analysis technique, and it is imperative that we get this one down because it'll be very useful for us in the future. Let's begin. Here we have a 50 volt source in series with a 5 ohm resistor in parallel with a 10 ohm resistor, 40 ohm resistor, and a 3 amp current source. Alright, we're going to solve this circuit using node voltage, and the first step for any node voltage analysis is to identify our nodes. I see one right up here, and we're going to call that one V1. I see another one. It might not be as important to label this one, but we're going to go through it for the sake of it. This is our ground node, and that's 0 volts. That's our reference node. Okay, so it looks like we have all of our nodes identified. So in order to solve the circuit, we need to sum the currents going in or out of our V1 node. I think I'm going to sum them in. So let me just draw those arrows. We're going this way. There, 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 and there. Okay, we're looking for currents here. So how do we get currents? Well, one way would be to use a voltage over a resistance. So let's start up here by the voltage source. On this side of the resistor, we have 50 volts, right? On this side, we have V1, whatever that might be. So the voltage across that 5 ohm resistor is going to be 50 volts minus V1. Okay, we have the voltage, let's turn it into a current. Let's divide all of that by 5 ohms. That is the current right here, going in to V1. Alright, let's try to find the current going in from the 10 ohm branch. So the voltage right here is 0. The voltage on that side of the resistor should be specific, and the voltage on this side of the resistor is also V1. So we're going to do the same thing. 0 volts minus V1 over 10 ohms. Same thing for the 40 ohm. Going to have 0 volts minus V1 over 40 ohms. And here we have it a little bit easier. 3 amps from that source is flowing into the node. Awesome. That's just plus 3. Set it equal to 0, and we now have an expression for the currents going in to our V1 node. And all we have to do is solve it. We have one equation and one unknown, so this is really just basic math. Let's go through it. All right, what do we got here? Let's separate these terms. 50 volts over 5 minus V1 over 5 plus 0 over 10. That doesn't make much sense. Let's just leave it out. Actually, minus V1 over 10 plus, I'm doing it again, minus V1 over 40 plus 3 equals 0. And just keep going. Let's 10 there, minus V1 over 5, minus V1 over 10, minus V1 over 40, plus 3. Let's move up here. I'm going to jump a little bit. 13 minus 8 V1 over 40 minus 4 V1 over 40 minus V1 over 40 equals 0. That's just for, all I did there was a common denominator. Let's add all those together. I'm going to get 13 V1 over 40 equals 0. 13 equals 13 V1 over 40. 40 times 13, 520 equals 13 V1. V1 equals 40. It's really that easy. Of course, you're probably going to run into a few circuits that have a lot more branches and you'll have to do a lot more sums. You're definitely going to have more nodes. But if you can get it into this form, matching the number of equations with the number of unknowns you have, you can do a system of linear equations and solve for it. It makes it real easy using this method. Thanks for watching.